All right, for Algebra 2, or sorry, pardon me, Algebra 1, we are doing lesson 3.2, ratios and proportions today. So first up, we have some vocabulary. All right, a ratio is a comparison of two numbers by division. It's written as a fraction, and then that says most often. It's not always a fraction, but most often, especially if we're working with it, is a ratio. A rate is a ratio, okay, it's a ratio, but it's comparing numbers with different units. Okay, so we might see miles um, per hour. Okay, that might be a unit. Okay, those are two different units. We have miles and we have hours. So that is a rate. We might see gallons per minute. Okay, if you were thinking about your faucet and how much water could come through your kitchen sink faucet, it might be in terms of gallons per minute. Okay, but that's a rate. And then we have a unit rate. All right, so this is the rate in which the denominator is 1. Okay, so the ones above that we talked about, miles over hours, generally like the speed limit is 60 miles per hour. That's a unit rate. Not only is it a rate, but it's a unit rate because it's per 1 hour. So if we look at the next one, it says these are all ratios. Circle the rates and square the unit rates. All right, so let's do that. If we have 45/60ths, okay, that's neither one, that's just a ratio. Okay, because for a rate and a unit rate, we have to have units. So the first one is just a ratio. 3 minutes per every 4 questions. Okay, so this is a rate, and the denominator is 4, so it's a rate and not a unit rate. The next one is 6 mph, which is miles per hour. Maybe that's your bicycling. So this is a unit rate because we would write it, it could be 6 miles per 1 hour. Okay, so 6 miles per hour, mph, is a unit rate because the denominator is 1. Okay, the next one, 1/3. That's just a ratio. Okay, it's not a unit, it has no units, so it cannot be a rate or a unit rate. The next one, 5,280 miles per 1 kilometer. Okay, so we have two different units, miles and kilometers, and our denominator is 1, so that's a unit rate. Okay, very nice. And the next one, we have 60 miles per. Okay, our division or fraction bar is a per. 2 hours. So we have different units. We have miles in the numerator, hours in the denominator, but our denominator is 2, so this is a rate. Okay, it's not a unit rate because the denominator is 2. So just slightly different there. All right, so let's look at example 1. A school of 312 students has 168 girls and 20 teachers. Find the following ratios. So A is the girls to student ratios. Okay, so typically we're going to write it as a fraction. So I'm going to write the girls and then the students on the bottom. Okay, so I write that just to help me remember. So my girls, I had 168 girls in class and 312 students. So 168 over 312, which can reduce, but I want to make sure you can write that. So we won't worry about the reducing part necessarily today, just writing the ratio. Okay, B is boys to students. Okay, so I want the number of boys to students. Well, I might have to do some math, of course, because I know there's 312 students, 168 girls, but I don't know how many boys. So the number of boys is going to equal 312 minus 168, right? So that equals 144. I don't want to write over my words there. So my ratio of boys to students is going to be 144 over 312. And I'm going to go ahead and write the reduced answer there. That is 6 to 13. And this one is 7 to 13. Which if I had reduced this one, it would have been a little easier because 6 plus 7 equals 13 because the students are either boys or girls. All right, next I want the girls to boys ratio. All right, so girls to boys ratio. And we can look back. We know there's 168 girls. So 168. And we solve for the boys, which was 144 over here. Or if we look at the reduced way to do it, it would be 7 over 6 from our reduced answer. Now, this is the unit rate. D is the unit rate of students per teacher. So we want students per teacher, or the student to teacher ratio, but then we have to take it down to a unit. So we had 312 students. We have 20 teachers. Okay, so we have to take that down to 1. So really we're doing 312 divided by 20. Okay, so that is 15.6 students per 1 teacher. And that is our unit rate because the denominator must be 1. So we divided both of those by 20. All right. Next up, a rate can be converted to an equivalent rate with different units. Okay, we've done this a little bit with dimensional analysis and the unit multipliers already. We've looked at that. But let's look at this example. We can change 60 miles per 1 hour to kilometers per 1 hour. Okay, so that's equivalent to 96.56 kilometers per hour. So that's all we're trying to do is convert to an equivalent rate, okay, with a different unit. And that is called dimensional analysis and using unit multipliers. Okay, so a unit multiplier is a rate with different units in the numerator and the denominator that represent the same quantity. Their value is always equal to 1, which is why we can use them. And multiplying by 1 or more unit multipliers renames the ratio. Okay, it's equivalent, but has different units now. So we've got to get this down. Example 2 says, use a unit multiplier to convert to the desired units. So 28 feet, 2 yards. So remember, we have 28 feet to start with. So we have 28 feet. We're going to multiply by a unit multiplier. We have to convert feet to yards. So we can use 3 feet per 1 yard, which is a unit rate, or we can use a different rate and say, well, 1 yard is equivalent to 3 feet. We choose which setup to use, okay, the unit rate or a rate, which one of these unit multipliers to use, depending on what we have in our numerator here. I have feet in my numerator, so I want to have feet in my denominator, so I can cancel those and switch to yards. So I'm going to use that one, 1 yard over 3 feet. Okay, that's the unit multiplier I chose. So now my feet will cancel because I have 1 in the numerator and 1 in the denominator. And this is equivalent to 28 yards divided by 3. And 28 divided by 3 is approximately, you guys have your calculator test, so you could use that. It's approximately 9.3 yards. Okay, you could use your calculator on that if you wanted. Because again, do you know how to set up the unit multiplier? That's what I'm concerned about, is setting it up and showing the steps. Okay, let's look at 2. We're converting 62 inches to centimeters. All right, so 62 inches is what we're starting with. So we've got 62 inches times a unit multiplier. And we need one that shows inches to centimeters. So are we going to use, there's 2.54 centimeters per 1 inch, or the unit multiplier that goes the other way and says, well, there's 1 inch for every 2.54 centimeters. All right, I have inches in my numerator here, so I want to use this one. So I have inches in the denominator. So 2.54 centimeters over 1 inch. My inches cancel, and now I'm left with 62 times 2.54, which again, you can use your calculator. You passed your calculator test, is 157.48 centimeters, because centimeters is the unit that remained. So that's why it goes in our answer. The same way with the other one. The feet canceled, and yards was the only thing left, which is why it was our answer, was in yards. Okay, that's why unit multipliers are so helpful, is they tell us what units we have. It shows how we eliminated units and how we kept units. Okay, let's flip over to the back and try example 3. About 8 minutes into liftoff, a space shuttle is traveling 17,000 miles per hour. How fast is this in feet per second? Whew, okay, so we've started with 17,000 miles per hour, and we want to know in feet per second. Okay, that's our goal. So I've given you all these to help you. 5,280 feet equals 1 mile. 60 seconds equals 1 minute. 60 minutes equals 1 hour. And 17,000 miles per hour equals this ratio set up, 17,000 miles over 1 hour. So you can use that. All right, because this is what we need to start with, right? This ratio right here. So we have 17,000 miles over 1 hour. So we're going to have to change our miles to feet and our hours to seconds. So it's going to require a lot of steps. So again, using those unit multipliers to get rid of each of those. All right, so first of all, let's change our miles to feet. Okay, so we're going to use this information right here. I know my miles are in the numerator, so I want this part, the 1 mile, in the denominator so they cancel. So I'm going to put 5,280 feet in my numerator. So now my miles are gone and I have the feet, so I can check that off. Now I need to change my hours to seconds. So I'm going to multiply by, okay, well, none of these say how many hours there are to seconds. So I have hours. Let's use this one to take my hours to minutes. Okay, so my hour is in the denominator right here. So I want the hour for this one in my numerator. So 1 hour equals 60 minutes. Okay, so at this point, my hour in the denominator and my hour in the numerator cancel. So I'm currently left with feet for 1 unit and minutes for my next unit, but I still want seconds, so I'm not done. I need to multiply by another unit multiplier. Okay, so this one has minutes to seconds. That's what I'm going for. So I have minutes here in my denominator. So I'm going to take this minute, this 1 minute, and put it in my numerator. So 1 minute is equal to 60 seconds. So I'm going to put 60 seconds in my denominator. Okay, now that that's done, my minutes cancel. And I'm left with feet here, and seconds is the unit, which is what I want, feet per second. Okay, so now I can do the math. What is 17,000 times 5,280 times 1 times 1 equal? Okay, you may not have had time to do the math there yet, but I have that equals 8976000 feet. So I'm going to put my feet in a different color, make sure you could see it. Okay, divided by What's 1 times 1 times 60 times 60? Well, that equals 3,600 seconds. Hopefully you can see that on the black. But here's the problem. The question asks for feet per second. It wants a unit rate, not a rate, which is what we currently have. Okay, this is a rate. We want a unit rate. So we need to divide like each of those to get a unit rate. So we divide by 3,600 because that's the unit. All right, so if we divide that to get it by 1, then we get 24,933.3 repeating feet over 1 second. All right, so approximately says how fast, because it's about 8 minutes into liftoff, how fast is this in feet per second? So we could say it's about 25,000 feet per second. Okay, so it's about 25,000 feet per second. I'm sorry if that was a little jumbled on the video and out of order. I had to pause it and recalculate my math because I had skipped this step in working it out in my book or showing it. So sometimes I don't always show all my work either. And it trips me up when I go to talk to you guys about it. All right, next up then, changing gears a little bit or adding on to this, is a proportion. All right, a proportion is a statement of equality, okay, between two ratios. So we've got a proportion right here. A over B equals C over D, which we actually read it as A is to B as C is to D. A and D are called the extremes, okay, they're on the outside, and B and C are called the means, if you need to know those. To solve a proportion, that's always going to be helpful. We do the products of the extremes. All right, so we're going to do A times D equals the products of the means. So we would do B times C. That's where this came from. AD equals BC. And that's called the property of proportions. Okay, so this over here is the property of proportions and how we solve them. Okay, so we're actually going to apply this property of proportions and solve some proportions. An example 4. Okay, if it'll clear. There it goes. All right, so let's use this property of proportions and solve them. So example 4a, we're going to do 7 times 4. So 7 times 4 equals 8 times x. All right, 7 times 4 is, or we could go ahead and divide by 8, and I'm going to do that actually so we can see some canceling happening so you can stay away from using your calculator. We can cancel 4 and 8. The 4 becomes 1, the 8 becomes 2. That yellow may not be the best color. Sorry about that. And so then we have 7 times 1 is 7 equals x. We're done. Oh, I'm sorry, 7 over 2. I forgot my denominator. I'm trying to rush through here. 7 over 2 equals x. Again, you can leave it as that fraction. If you want to make it a decimal, 3.5 is fine. Just as long as you know and you're showing what you're doing. All right, for the next one, same things. We're going to do multiply the extremes. So x plus 9 times 7. So we're going to have the quantity x plus 9 times 7 equals 5 times the quantity x plus 15. Okay, in this case, we have the distributive property, so we have to distribute first. So we're going to, even though the 7 is behind, it's still the distributive property. So we're going to have 7x plus 63 equals 5x plus 5 times 15 is 75. And then we're going to solve this equation like any other. Okay, so I'm going to subtract 63. I'll have 7x equals 5x plus 75 minus 63 is 12. Okay, I'm going to subtract 5x. 7x minus 5x is 2x equals 12. Okay, I would divide by 2 and have x equals 6 right there. All right, so we just solved the proportions here. We found x using them. All right, example 6, we can do the same thing. We're going to use a word problem to do that. So a car traveled 250 miles on 9 gallons of gas. How many gallons are needed to travel 360 miles? All right, well, we're talking about proportions, so we're going to set up this proportion. All right, so we've got it traveled 250 miles on 9 gallons of gas. So I'm going to write some notes. I'm going to do miles to gallons for my proportion. Okay, so if he traveled 250 over 9, okay, and so that's going to equal my other proportion, and I want to travel 360 miles. So am I going to put that in my numerator or my denominator? Well, that's why I wrote this to help me remember. Since this is miles, I'm going to put it in my numerator where I had it labeled miles, and then I'm going to put my x down here. Okay, and then I can solve. All right, so to solve, I'm going to have 250 times x equals 9 times 360. All right. Again, at this point, I'm going to go ahead and divide by 250 because I know I don't have to distribute or anything. All right, and I can cancel. So I could divide by 10. That would get rid of my zeros. I'd be left with 9 times 36 divided by 25. That's okay. You also have your calculator, so you could do that math. That's okay too. So x is going to equal what? 9 times 36 divided by 25 is going to give you 12.96. And I need a unit. What should my unit be? Again, if I go back to look here, right, x was right here in the denominator, so what should I use for my unit? Yes, it should be gallons. Okay, so again, it's also in the question, how many gallons, right? How many gallons? But I've used this ratio setup to help me know where it goes, like where is x? That's why, again, showing your steps and how you're solving it are very helpful. Okay, example 7 on your next page is the last one we're going to work through. And then you have your on your own. So example 7. A car dealer typically sells new and used cars in a ratio of 3 new cars to 2 used cars. If he wants to sell a total of 325 cars next month, what goal should he set for the used car sales manager? Okay, so if we look at this one. So he sells new and used cars in a ratio of 3 new cars to 2 used cars. Okay, so that's that 2. So we've kind of got 3 used. Okay, oh no, 3 new, pardon me. So we've got a ratio of 3 new to 2 used. All right, and it might help us to think about the total. So we've got 5 cars here total. All right, that could be helpful to have a total. All right, so he wants to sell, right? He wants to sell, this is what we're looking for, a total, see, we did need this total. He wants to sell a total of 325 cars next month. What goal should he set for the used car sales manager? So this is helpful, okay, because we know that he wants to sell a total, and we want to know about the used car sales manager. So our ratio needs to involve those two, or our proportion actually, needs to involve the used and the total. So I'm going to set mine up with the used in the numerator and the total in the denominator. Okay, so I need to use the information that I was given. So I know that typically they sell 2 used for every 5 cars total. So that's 2 over 5 equals what I want to find out. So now he wants to sell a total of 325 cars. So in my next ratio, 325 is going to go in my denominator because that's where the total is. And I'm going to put my variable in the numerator to know how many used cars I need to sell. And we could have used any letter. X is just simple. All right, so now we're going to do our property of proportions and do our cross products. So we have 2 times 325 equals 5 times x. All right, and we're gonna go ahead and divide by 5, and I can cancel. All right, so 5 is going to turn into 1. 325 divided by 5 is 65. So then I'm left with 2 times 65 equals 130 equals x, because these 5's canceled. So 130 equals x, but I need a unit, right? What goal should he set for the used car salesman? Okay, so this is 130 used cars is what he should set, that goal. For the used car salesman to sell 130 cars. Okay, you have a few on your own problems there to work out, and the sub will have your notes for you. So check them. Good luck. I think you guys will do great.